Hi, welcome back. So in this video, we're going to talk about the time to event analysis dataset. So this is another video for time to event in the series of Adam training. Okay, so the comprehensive guide for statisticians, the data managers in a clinical research. So my name is myself, Ali Shaikh. I'm the consultant at Trial Optima Inc. So this training module covers the foundational elements of the time to event analysis datasets within the ADAM framework. So the version will be 2.1 and the implementation guide is 1.1 section 3.36. So where you can see the time to event variables for BDS data structures. Okay. So the three core concepts of the table of contents, the overview. So overview of the ADTE is what are the fundamental concepts and the structure and applications of ADTE in the clinical trials. And what are some examples of common statistical methods, the implementation of survival analysis techniques with ADTE datasets. So we'll be having some important notes about ADTE, the special considerations and best practice for the time to event data management. So the overview of ADTA, the specialized application for Adam basic data structures. So it is designed to support survival analysis in clinical trials. So it will be having all the still needed like treatment TRT01P, TRTP, param, and aval, and we'll be having the timing variables and the traceability variables. This is a specific variable. There are some specific variables for ADTT. That is the start date and sensor and event descriptions. So those will be discussed in the later slides. So the definition and purpose. So the special application of the Adam BDS for survival time to event analysis. So the measured time until occurrence of specific events from predefined starting points, and it supports the multiple efficacy and safety endpoints, and the subject without events within the evaluation periods are censored. So the some of the common applications in the IDTT, so we'll be having over survival, progression free survival, and time to first occurrence of the adverse events. And the supported analysis types are single event with binary values for censoring variables, single event with multiple values for censoring variables, and the composite event analysis. And there are some limitations. So the recurrent event analysis are not compliant with the BDS structures, as they are required more than one analysis variable as dependent variables. Okay, so let's go for the next slide. So there are some common variables ADTE. So as I mentioned, they will be having the treatment identifiers, the parameter identifiers, aval, analysis values, analysis date, analysis visit identifiers, and the source domain, source variable, source sequence, data point traceability variables, and ADTs. There are some ADTT specific variables, the start date at which subject is first at risk. The sensor indicates if the record is censored event, and event description describes the event of interest or censoring. So sensor date, so describe the circumstances represented by the censoring date. So these variables create the foundation for properly structured time to event analysis that comply with the regulatory standards. Okay. Okay, so so the overview of the ADTT, the common statistical method supported by the ADTT. So ADTT support industry standard survival analysis techniques required for regulatory submission and clinical decision making. So the examples of common statistical methods, so the Kaplan-Meier analysis, the non-parametric estimation of the survival function, providing survival probabilities. Okay, so at different time points. So here the hazard ratio estimation, so quantification of the treatment effect through ratio of hazard rates between groups, and log rank tests, so statistical test comparing survival distribution between the treatment groups, and the Koch proportional hazards regression models examine the relationship between survival time and predictor variables. So one example, the SAP definitions. So here so the overall survival is defined the date of death due to any cause, the start of minus the start of date of treatment, and that and divided by 30.4375. Subject with the no documented death will be censored at the last date known to be alive. The Kaplan-Meier estimates will include number of percentage events censored. Okay, so the survival quarters and the 95% confidence intervals, and survival rates with the 95% at a pre-specified time points. The key implementation steps identify what constitutes an event, death due to any cause, define censoring rules, no documented death equal to censor. So establish evolution period, treatment start to death or last known alive. Okay, so what does it indicates? Basically, like if the subject is censored, like if it is a zero, that means it's death of the particular subject, and if it is one, that is the last date known to be alive. Basically, it is censored. So we'll be have like in the compliant mayor estimates to evaluate the based on the time the subject is survival rate as the treatment is progressing during the time limit. If it is stay like stable, I mean the graph is like stable, then means the subject is stable, not having any like the disease is progress. So if it is falling, like if it is fall, so basically this graph is wrong. So it has to be on other side. So what I'm saying, the Kaplan-Meier the plot is basically to evaluate the overall survival rate based on the treatment. Based on the treatment is progressing, how the subject is behaving as the time is progressing with the treatment. Okay. So the next one would be, so here the some of the building ADT metadata. We'll be having the param city analysis value start date. So analysis value, you can see the analysis date minus start date plus 1 cross divided by 30.4375, and ADT the value analysis date and sensor and the event description. This metadata structure provides a traceable reproducible framework for survival analysis that aligns with regulatory requirement and support statistical analysis. Okay, so the next one will be the advanced survival analysis in clinical trials. Okay, so overall survival example number one, the ADDT dataset with the binary censoring values. The binary censoring represents the straightforward implementation where sensor equal to 0, event occurred death documented, and the sensor equal to 1, subject was sensor alive at last follow-up. This approach provides clean satisfaction for Kaplan-Meier estimation and Cox proportional hazard modeling. Okay, so as I mentioned, the Kaplan-Meier plot. So basically, you evaluate the overall survival rate for the subject as the treatment progress during the time how the subject was behaving. If there is any event is occurred, if the sensor is 0, then the event has happened, and if there is no information, and if the subject was dead without having any information at last follow-up, then it will give you as a sensor equal to 1. So because of this graph, we can estimate like how the treatment is progressing for that particular subjects. So ADT dataset with the multiple censoring values. So the multiple censoring values allow for the more detailed organization categorizations for why the subject exists. The analysis sensor equal to 0, so event occurred death. So these are the values for the sensor variable. So sensor equal to 1, administrative sensor. So if it equal to 1, then is administrative censoring study end, and sensor equals to last follow up. So the progression-free survival example number 3. So ADTT dataset with composite endpoints. Composite endpoints combine multiple clinical events into single time to event analysis. Sensor equal to 0, event occurred, progression or death. Sensor equal to 1, subject was censored. Okay, so param city identify the specific type of event, while param provides the full description of the ending point being measured. So this is also another endpoint for the to evaluate of the oncology or any therapeutic related endpoint by using the time to event dataset. Okay. So other important notes about ADTTE. So critical consideration for properly implementing ADTT in clinical research. So the source domain considerations, the source domain origins, ADT may derive from either SDTM or other ADAM datasets. When events are derived parameters, intermediate datasets are required. And visit window is when exact event times are unknown due to visit schedules required interval censoring. A analysis visit indicate which study visit is associated with the event. So if there is unknown visit, we have to calculate the visit windowing concept based on the SAB. So interval concerning critical for events occurring between the scheduled visits, used for disease progression or status changes, account for uncertainty in exact event timings. So this is it about ADTT. So these are the variables we mostly use in ADTT data structures. Okay. All right. That's it. This video. Thank you so much for watching. We'll continue for the further classes. Thank you.